Hi, today we're talking on Beyond Pixel, semi-supervised semantic segmentation with a multi-scale patch-based multi-level classifier. Coming to the research topic, we're dealing with semi-supervised semantic segmentation, which involves training a segmentation network on limited labeled data and a large amount of unlabeled data. The existing approaches follow a teacher-student framework, for example, Unimatch and Oxide. But following this framework introduces two specific challenges. The first being, this framework introduces pixel-level consistency, which does not explicitly exploit contextual information. The existing methods introduce context, like in convolution network, it is controlled by AEL, it is controlled by the kernel size. Transformer-based methods like segformer cannot be applied because they don't work so well in limited label data scenarios. Coming to the second challenge, so for an unlabeled image, the teacher and the student sees two different augmented views, and the teacher generates pseudolabels to train the student. But these pseudolabels can be noisy. So we propose processing patches within images to introduce contextual information and detecting noisy labels within a patch. So say we have this red box at a boxed area, this area inside this patch, and if we train a multi-level classifier which uses the initial embeddings from the segmentation layer for this area, we get the following classes like road, car, truck. Now, because we are training the multiple classifier along with the segmentation network and as an auxiliary loss, it forces the initial layer features to still contain enough information of patch level information to be able to, so that the multi-level classifier can correctly classify. This is how you introduce context. Further here, if you see, there is no truck in the patch. So the multi-level classifier is not so confident for truck. So we can use the confidence of a multi-level classifier for a particular class in a patch to say if that class is noisy or not. So coming to our formalized proposed solution, we have introduced a novel plugin module multi-scale patch-based multi-level classifier, which consists of two adaptive weights that reduces the influence of noisy pseudolabels. Further, we have validated by integrating it to 4 semi-supervised segmentation methods with consistent improvement in natural and medical dataset. Coming to our proposed solution, let's take a small example. We have taken a small patch in different images from cityscapes, and we see the segmentation output and the classification output after training for 20 epochs. We observe that the segmentation classifications can be wrong while the multi-level classifications are correct. So when we train our baseline model with MPMC, we see there's an improvement in the overall segmentation. Coming to our overall pipeline, we have a tier-student network with the plugin module MPMC. The segmentation network is trained by cross-entropy laws, while multiple classifiers are trained by asymmetric binary cross-entropy focal laws. So first we have a tier-student network to which we have introduced MPMC, which is trained on labeled images by LML. For unlabeled images, we have LMU. But to reduce the noise on the unlabeled images for the multiple classifier, we introduce pseudo-label patch weighing. And to reduce the effect of noisy pseudolabels on the segmentation network, we introduce pseudo-label pixel weighing. Coming to MPMC, we have a segmentation network from which we take the initial features to train a multiple classifier, based on which we define the two weights. So here you see we train in a multi-scale approach a multi-level classifier based on the initial features of the segmentation network. Now, based on the predictions and the confidence of the predictions, we first define lambda m, which is used to reduce the effect of noise on the multiple classifier, and we also introduce lambda s, which is more pixel level weighing. We observe that from our experiment that we improve the baselines, and further we have shown improvement in particle views in AC/DC. Coming to the qualitative results, we observe that our method improves the segmentation, as can be seen from the areas in the white boxes. Coming to the conclusion, we have introduced a plugin module, MPMC, which introduces patch level context information and reduces the effect of noisy pseudolabels in semi-supervised segmentation. Further, we have validated it on 4 semi-supervised segmentation methods across 3 datasets. So if you are considering semi-supervised semantic segmentation, please consider using MPMC.